Welcome to the first episode of our series on speaker systems. In this series, we'll explore the basic principles and specifics of speakers, focusing on their electrical, mechanical, and acoustic characteristics. If you're an audio enthusiast, a budding engineer, or just curious to know how speakers work in extensive detail, this series is for you. The first rudimentary form of a speaker was invented by Alexander Graham Bell in 1876, followed by several other inventors and engineers such as Ernst Siemens and Peter L. Jensen. The early form of speakers consisted of a diaphragm attached to a voice coil within a magnetic field to produce sound. This design laid the foundation for modern speakers, and it remains the basis for most speaker systems to this day. Despite the rapid advancements in electronics and technology over the past century, the basic format of speakers has surprisingly remained unchanged. While digital audio and video equipment, computers, and network systems have undergone revolutionary transformations, the fundamental principles of speaker design have endured. This is largely due to the fact that the physics governing sound reproduction through speakers are deeply rooted and have proven difficult to revolutionize. The anatomy of speakers, with components such as voice coils, magnets, cones, and enclosures, remains relatively simple yet highly effective. Even with the advent of digital signal processing and advanced materials, the basic principles of converting electrical signals into sound waves remains consistent. In modern implementations, speakers have found their way into a vast array of applications, from home audios to concert venues, from theatrical systems to smartphones. While advancements in materials, manufacturing techniques, and signal processing have led to numerous improvements, the fundamental design principles of speakers did not change. In spite of the relatively simple anatomy of speakers, the basic principles encompass several significant areas of physics including the electronics, mechanics, and acoustics. The understanding of speakers often starts with the consideration of the electrical system that they are built around. From an electrical standpoint, a speaker can be understood as primarily an inductive load with some resistance, which will be connected to the output of an amplifier. Amplifiers are of major concern in electrical engineering because they are the building blocks in most electronic systems. The speakers, on the other hand, are often regarded simply as inductive loads with quirky frequency responses across the audio spectrum. In an electrical system, the primary concerns regarding speakers lie in their impedance and efficiency, specifically in their ability to efficiently reproduce the power output from the amplifier. When it comes to faithful sound reproduction, there are additional nuances to consider, such as harmonic distortion and intermodulation, among others. However, these aspects often remain within the concerns among audiophiles. Interestingly, the distortion levels in speakers often exceeds the distortion in amplifiers or other audio components by orders of magnitude, although they're not as frequently discussed as their amplifier counterparts. During the early stages of audio technology, amplifiers were notably less efficient, and the wattage of their output was a key metric for assessment. Consequently, speakers were required to exhibit high efficiency to produce loud sound with minimal power input from the amplifier. However, the impedance curve of a speaker tends to deviate significantly from flatness across the frequency range, largely due to mechanical resonance and the inductive nature of the voice coil. With the significant advancements in amplifier technology in recent years, the cost of power has drastically reduced from what it once was. The emergence of Class D amplifiers, often incorrectly labeled as digital amplifiers, now offers power outputs in the range of several hundred watts or more, all at a fraction of the price of meticulously crafted interconnect cables. Given this abundance of affordable amplifier wattage, the efficiency of speakers is no longer as critical a concern today. Instead, there's a growing trend towards leveraging this surplus power to enhance the frequency response of speakers, aiming for a higher level of flatness. However, this pursuit of frequency response refinement comes at the expense of efficiency. Many speakers incorporate multiple driver units dedicated to different frequency ranges, necessitating the integration of these units through appropriate crossover filter circuitry. These circuits, typically comprising high and low-pass passive filters, further influence the impedance curve. Effective integration of high and low-frequency units is crucial for achieving consistent sound reproduction across a broad audio spectrum. Some speakers, usually known as active speakers or powered speakers, come with built-in power amplifiers enclosed within the speaker cabinet. These speakers may include active crossover filter circuits or digital signal processing, DSP, to compensate the irregularities in the frequency response. While this integration can equalize the frequency response to some extent, it cannot circumvent the fundamental laws of physics nor eliminate all the inherent size-related limitations of their class. Metrics such as impedance curve, efficiency, and frequency response serve as primary indicators of speaker performance. However, assessing other physical aspects such as mechanical and acoustic properties can be challenging from an electrical standpoint. These properties are often represented through equivalent values, as commonly found in Thiele small parameters. The advancements in modern amplifier technology have reached a point where they can effectively drive speaker systems with both power and accuracy, and the speakers now deserve more attention from mechanical and acoustic standpoints. The simplistic analogy of a speaker as merely an equivalent inductive load does not suffice to capture its complexity. The mechanism of a speaker cannot be fully understood without knowing its mechanisms encompassing multiple principles. While the electrical aspects of a speaker are important, understanding its mechanical and acoustic characteristics can clarify specifics beyond mere electrical considerations. This will be our next topic of exploration into the intricate nature of speaker mechanics.